In this video, we'll go through exam questions that cover the criteria, recognize and make use of simple scales on maps and drawings. You can locate the questions on the mathsmaths.com website under Level 1. The questions come from different exam boards. We'll start with the non-calculated questions and then we'll move to the calculated questions. Here is the first one. Alan works at a warehouse in Runcorn. A furniture company needs deliveries from Runcorn to Liverpool, Runcorn to Nantwich. Alan needs to work out the total delivery charge for these deliveries. He uses this map. Got a scale, 1 centimetre on the map is 10 kilometres on the ground. Alan uses these delivery charges. Distance from Runcorn, less than 20 kilometres, charge £9.99. Between 20 kilometres and 35 kilometres, £14.99. Over 35 kilometres, £24.49. Work out the total delivery charge. Show how you get your answer. So the first thing to do is to measure the distance with a ruler. So Runcorn to Liverpool, measuring it with a ruler as printed on paper, this will be 2.7 centimetres. And the distance from Runcorn to Nantwich will be 4.2 centimetres on the map. So let's work out the distance on the ground. I've got the scale 1 centimetre to 10 kilometres. What about 2.7 centimetres? To get from 1 to 2.7, we multiply by 2.7, so we'll do the same here. 2.7 times 10. So that means moving the decimal point one place to the right. So this becomes 27 kilometers. 27 kilometers, that is between 20 and 35 kilometers. Charge for that is £14.99. Then we have Runcorn to Nantwich, which is 4.2 centimeters. So again, using the same scale, 1 centimeter to 10 kilometers, we've got 4.2 centimeters on the map. So 1 times 4.2 gives us 4.2. So now 10 times 4.2 will give us 42 kilometers. So that is over 35 kilometers, which gives us £24.49. We're working out the total for the delivery charge, so we're going to add £24.49 to the £14.99 that we have there already. So 9 and 9 gives us 18, so 8 down and 1 carried over. 9 and the 1 that we carried over makes 10, and the 4 that makes 14. So 4 down, 1 carried over. 4 and 4 is 8, and the 1 is 9. 1 and 2 is 3. So £39.48. 14 kennels have enclosures where the animals sleep. Each enclosure must be a minimum of 1.8 meters high and 0.9 meters wide. This is a scale diagram showing the front view of the enclosure Linda wants to install. Is this enclosure big enough? Show how you decide. Okay, so we're told that it must be 1.8 meters high and 0.9 meters wide. We've got the scale diagram, and it says scale 1 centimeter to 20 centimeters. So 1 centimeter on the diagram is 20 centimeters on the ground, or in reality. So 5 centimeters, what is that in reality? How do we get from 1 to 5? By multiplying by 5. 1 times 5 gives us 5. So we'll do the same here. 20 times 5, what is that? 2 times 5, that is 10. Add in the 0, that gives us 100 centimeters. So, in reality, this is 100 centimeters, which is also 1 meter. Now let's look at the height. So using the same scale, 1 centimeter to 20 centimeters, this is 9.5 centimeters. So 1 times 9.5 gives us 9.5. So we'll do the same here. That's 20 times 9.5. 0 times 5 is 0, 0 times 9 is 0. Moving down, so we put a 0 first. 2 times 5 is 10. So 0 down, 1 carried over. 2 times 9 is 18, and the 1 is 19. So 0, 0, 9, 1. We're going to give this 1 decimal place because 9.5 has 1 decimal place. 20 doesn't have any decimal places, so it's a whole number. So the number, the answer, will have 1 decimal place in total. So going backwards, I'll put the decimal point here, so that gives us 190 centimeters. There are 100 centimeters in a meter, as you know, so this is 1.9 meters. So let's compare them now. Minimum is 1.8 and this is 1.9, so that works. And then minimum for the width is 0.9 meters, and in fact this is 1, which is greater. So to answer the question, is this enclosure big enough? We're going to say yes, and we've shown the working out, which in fact you will need to work it out, show it here within the box. But I didn't want to scroll up and down, so I did it on that page. Janice wants to buy a table to put in her patio area. She draws a diagram for her patio to show the size of table she wants. What are the actual measurements of the table Janice wants? We're given the scale, which is 1 box is equal to 20 centimeters by 20 centimeters. So that's the dimensions, 20 centimeters by 20 centimeters. So we have table. Let's do the length first. So that is 20 centimeters, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220. So that's 220 centimeters by 20, 40, 60, 80, 100 and 10. So that's half the box, half the length. So 220 centimeters by 110 centimeters. Or 2.2 meters by 1.1 meters. Erin runs a gardening company. A customer has asked Erin to design and build a new garden. The garden will be a rectangle measuring 11 meters by 9 meters. Here is a list of what the customer wants in the garden. A paved area, 2 meters by 2 meters square, in one corner. A hedge, 6 meters by 1 meter rectangle, along one edge. A flower bed, which is a circle with a radius of 3 meters. On the scale diagram below, show a possible design for the garden. We've got the scale, which has 1 centimeter represents 1 meter. Let's take this in turn. So the garden will measure 11 meters by 9 meters. So that will be 11 squares by 9 squares here in the grid. So let's just count these. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's exactly the size of the garden. Now we've got to draw the paved area, which should be in a corner, so 2 meters by 2 meters. So that is 2 squares by 2 squares. Just going to do it here. I say 2 squares because we've got here that 1 centimeter represents a meter. So 2 meters will be 2 squares. And the length of each square is on the grid 1 centimeter. So we've done the paved area. Now hedge, which is 6 meters by 1 meter rectangle along one edge. We can do it next to the paved area, so that will be 6 squares by 1 square. So 1, 2, 3, 4, 5, 6 by 1 square. I'm going to label it. And then flower bed, which is a circle with a radius of 3 meters. So radius of 3 squares. So if we do it here, right in the middle, so we have the center in the middle. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So the radius is that distance from the center of the circle to the circumference. You'd need to use a compass to draw this accurately, but this gives you an idea. The table shows the amount that Erin charges the customer. Designing the garden, £49.99. Materials, £62.73. Building the garden, £10 per square meter. How much does she charge altogether? The garden was 11 by 9 meters, so 11 times 9 gives us 99 square meters. And she charges £10 per square meter, so we're going to do 99 times 10. So that means we add in a 0 at the end of 99. So that gives us £990. Then we have the £49.99, £62.73. So we'll add all of these together. 9 and 3 is 12, so 2 down and 1 carried over. 9 and the 1 we carried over is 10, and the 7, 17, so 7 down and 1 carried over. 9 and 1 is 10, and the 2 is 12, so 2 down, 1 carried over. 9 and 1 is 10. 6 and 4 is 10, so 10 and 10 is 20. 0 down, 2 carried over. 9 and 2 is 11. So that gives us £1,102.72. The paved area is a square with sides 2 meters long. The paving stone for this area are squares that measure 50 centimeters by 50 centimeters. How many paving stones are needed? 1 meter is equal to 100 centimeters, so 2 meters will be equal to 200 centimeters. So this is a square. So 200, how many 50s fit into 200? It's 4 of them. So you can imagine 4 along the length and 4 along the width. So it will look like this. 4 times 4 is 16. So 16 paving stones are needed. Hanifa is planning a party. Hanifa hires a hall for the party. The hall is a rectangle and measures 12 meters by 9 meters. Here is a list of what she wants in the hall. DJ table, 1 meter by 2 meters rectangle. Refreshments table, 1 meter by 3 meters rectangle. Dance floor, 5 meters by 5 meters square. There must be a space of at least 1 meter around each table. On the scale diagram below, draw and label a possible plan for the hall. We've got the scale, which says that 1 square represents a 1 by 1 meter square. So that tells us that the DJ table will have dimensions of 1 square by 2 squares. Refreshments table, 1 square by 3 squares. Dance floor, 5 squares by 5 squares. Or 5 square lengths, I should say. So let's start with a DJ table. 1 by 2. And we've kept a space of 1 square around each table. At least for now, around the DJ table. Then we have the refreshments table, which is 1 meter by 3 meters. So I'm going to keep that space. So 1 by 3. And that is refreshments table. And then the dance floor, 5 meters by 5 meters. So we could do it here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And let's just double check. DJ table 1 by 2. And we've kept the space around. Refreshments table 1 by 3. We've kept the space around as well. Dance floor 5 by 5. That tells us that we've done everything correctly. Here are the amounts Hanifa spends on the party. DJ hire £433, food and drink £278, hall hire £11.50 per hour, dance floor hire £10 per square meter. The hall is hired for 4 hours. Show that altogether Hanifa spends £1,007. So we have £433, £278, hall hire £11.50 per hour, and it was hired for 4 hours. So £11.50 times 4. 4 times 0 is 0, 4 times 5 is 20, so 0 down, 2 carried over. 4 times 1 is 4, and the 2 is 6. 4 times 1 is 4. I'm going to give the answer 2 decimal places, so 1, 2, that gives us £46. Now we've got dance floor hire, £10 per square meter. The dance floor was 5 meters by 5 meters. So that will be 25 square meters. 25 times £10 per square meter gives us 250. So adding these numbers together, 3 and 8, that is 11, and the 6, that is 17. So 7 down, 1 carried over. 3 and 7 is 10. 4 and 5 is 9, and the 1 we carried over is 10. So 10 and 10 gives us 20. 0 down, 2 carried over. 4 and 2 is 6, and the 2 is 8, and the 2 is 10. So that is £1,007. So we've shown the cost. Now we move into the calculated questions. Chris is designing a badge. The badge needs to be in the shape of a trapezium, have a base of length 6 centimeters, have only one line of symmetry. Draw a suitable badge. Use the grid below to draw a badge. We're given that the square is 1 centimeter by 1 centimeter. So we can start with the base, which needs to be 6 centimeters. So that will be 6 square lengths. It's got to be in the shape of a trapezium. And it needs to have only one line of symmetry, and that could be here. And that could be a possible design. It's a trapezium, has the base with length 6 centimeters, it has only one line of symmetry. You need to use a ruler to draw it accurately. Karen is making a birthday cake. The top of the cake needs to be triangular with one side length 10 centimeters, one side length 12 centimeters, and a 90-degree angle between these sides. Draw the top of the cake for Karen. Use the grid below to draw the top of the cake. We're given that each square is 2 centimeters by 2 centimeters, so 10 centimeters will show with 5 square lengths and 12 centimeters with 6 square lengths. So if I start by showing that the first one, so 1, 2, 3, 4, 5, then there will be a right angle, so 90-degree angle in the middle. So that will go like this. Then we'll have 1, 2, 3, 4, 5, 6. So that's the angle. That's the 12 centimeter length, and that's the 10 centimeter length. Now all I need to do is join these 2 points to make a triangle. And of course you'd use a ruler to draw this, but it gives you an idea of what you do on paper. Sam wants to create a space for water play in the village hall. He has his diagram of the floor in the village hall. The space for water play must be in the shape of a rectangle, 3.5 meters by 4 meters, at least 2 meters away from other activity spaces, at least 3 meters away from any door. Draw a space for water play on the grid below. Key: 1 square length on the grid represents 1 meter on the village hall floor. So In grey, we've got the activity space, and then that bold line shows us the door, where the doors are located. Since 1 square length on the grid represents 1 meter on the village hall floor, that tells us that the water play will have these dimensions 3.5 square lengths by 4 square lengths. We'll stay 2 meters away from other activity spaces, so that is 2 square lengths, and 3 square lengths from any door. So let's just start here. Then we have a door, so 3 square lengths, 1, 2, 3. So 4 by 3.5. What if we do it here? So 1, 2, 3, 4 by 1, 2, 3.5. So that gives us the distance from the slide as well, which is 2 square lengths. So the water play can be put there. Because we've met all the criteria. It is 3.5 by 4 square lengths. It's at least 2 meters away from other activity spaces, and it's at least 3 meters away from any door. John is organising a charity sailing race on the sea. He starts to draw this accurate scale map of the course. Key: 1 centimeter on the map is half a kilometer on the sea. Sailors begin the race at the start and follow the course to the finish. John says, the course has a total distance of more than 18 kilometers. Is John correct? You must show your working. So the first step would be to use a ruler to measure these. So we'll add all of the distances from start to A, B, C, D, E, and then finish. So we've got 3 centimeters and 4.5, 6.5, 4 and 6, which is 10, and the 9, that's 19. 5 and 5 is 10, so 0 down and 1 carried over. 9 and the 1 makes 10, 6 and the 4 makes 10, so that's 20, and the 3, that is 23. So 3 down and 2 carried over, 2 and 1, that is 3. So that is 33 centimeters in total. We're given the scale, which is 1 centimeter on the map is equal to half a kilometer on the sea. What about 33 centimeters? How many kilometers will that be on the sea? Well, if you look at the scale, it says 1 centimeter to half a kilometer. So the number of kilometers is half the number of centimeters. So all we need to do is halve the 33. So 33 divided by 2. How many 2's fit into 3? That's 1, and we have 1 remaining. How many 2's into 13? That is 6, and we have 1 remaining. So we can add a 0 now. How many 2's into 10? That is 5. So 16.5 4.5 kilometers. And John said that the course has a total distance of more than 18 kilometers, but that is not more than 18, it's less than 18. So is John correct? We're going to say no. Chester makes this scale plan of one of the rooms. What is the actual length of the longest wall in meters? So the longest wall is this one. We're given that 1 square is equal to 50 centimeters. So 2 squares will be 100 centimeters, which is 1 meter. So that's 1 meter, 2, 3, 4.5. So 4.5 meters. Asha plans to cycle from the Hook of Holland to Amsterdam. Her map has a scale of 1 centimeter to 8 kilometers. The straight line distance between the Hook of Holland and Amsterdam is 70 kilometers. What is the measurement between these two places on Asha's map? Give your answer in millimeters. So the scale is 1 centimeter to 8 kilometers. 1 is for the map and 8 kilometers, that is in reality or on the ground. So now it says that the straight line distance between the Hook of Holland and Amsterdam is 70 kilometers. So that is in reality. We're going to work out the distance on the map. So how do we get from 8 to 70? What do we multiply 8 by? So we'll do 70 divided by 8, which is 8.75. So we'll do the same here. 1 times 8.75 gives us 8.75 centimeters. So that is in centimeters, but we've got to give our answer in millimeters. So we know that in 1 centimeter there are 10 millimeters. So in 8.75 centimeters there will be 10 times more millimeters. So we'll do 8.75 times 10, which is 87.5 millimeters. Asha will spend 2 days in Amsterdam and then cycle back to catch the ferry at the Hook of Holland. The road distance between two places is about 40% longer than the straight line distance. Estimate the actual road distance Asha will cycle in total. Give your answer in kilometers. So the straight line distance was 70 kilometers. We're going to work out 40% of 70. So 40 divided by 100 times 70 gives us 28. So we can add 28 kilometers now to 70 because it's 40% longer, which is 98 kilometers. The tourist wants to know how long it will take to walk to a museum. This map shows the route from a nearby station to the museum. The route measures 6.5 centimeters on the map. It takes a tourist 10 minutes to walk a kilometer. How long will it take him to walk to the museum from the station? Give units in your answer. So we're given that the length of this route on the map is 6.5 centimeters. We know that 1 centimeter represents 100 meters. So the scale is 1 to 100. So 6.5 centimeters. What is that in reality? So 1 times 6.5 gives us 6.5. So we'll do the same here. 100 times 6.5 will give us 650. That is meters. So 650 meters. We know that it takes a tourist 10 minutes to walk a kilometer. So 1 minute will be 10 times less than a kilometer. We know that in a kilometer there are 1,000 meters. So what is 10 times less than that? 1,000 divided by 10 gives us 100 meters. So he can do 100 meters in 1 minute. What about 650 meters? What do we multiply 100 by to get to 650? So we'll do 650 divided by 100, which is 6.5. So we'll do this here, times 6.5. 1 times 6.5 gives us 6.5 minutes. So it will take him 6.5 minutes to do the distance. The owner of a trampoline park has a floor plan. She wants to put 4 trampolines in zone 3. She needs a scale diagram to see where the trampolines will go. Each trampoline measures 3 meters by 1.8 meters. She wants them placed with 2 lines of symmetry in zone 3. Complete the plan below to show the positions of the trampolines. Draw the 2 lines of symmetry. So here is zone 3. We're given that the square length is 1 meter. So each trampoline will be 3 square lengths by 1.8 square lengths. So 1, 2, 3 by 1.8. We need 2 lines of symmetry, so we can draw them here. So there is one, and another one which can go here. So I'll reflect this trampoline on the other side. So 1, 2, 3, and then going down 1.8. Then I'll repeat this on the other side. So 1, 2, 3, 1.8, 1, 2, 3, 1.8. So we've got 4 trampolines, each of them measuring 3 meters by 1.8 meters, and we've got the 2 lines of symmetry. All of this within zone 3. A farmer uses a drone to monitor animals. The drone can fly a distance of 8 kilometers when its battery is fully charged. The drone has a quarter of its battery life left. The farmer needs to know if the drone has enough battery to complete this route shown, starting from his farmyard. Does the drone have enough battery life to complete the route? Explain your answer with figures. So when fully charged, you can do 8 kilometers. Now it only has a quarter of the battery life left, so you can only do a quarter of the 8 kilometers. So 8 divided by 4 gives us 2. So you can do 2 kilometers. We know that in 1 kilometer there are 1000 meters, so this is equal to 2000 meters. We've got the scale which says that the square length is equal to 100 meters. So here is the start. So this will be 100, 200, 300, 400, 500 meters so far. 600, 700, 800, 900, 1000, 1100, 200, 300, 400, 500, 600, 700, 800, 900, 2000, 2100, 200, 300, 400. So it's 2400 meters. Because it was 24 square lengths times 100 meters each, which is 2400 meters. So that is not enough. With the battery life left, the drone can only do 2000 meters, not 2400 meters. Using the scale, what is the distance between points A and B in miles? 1 kilometer is equal to 0.62 miles. We've got a scale which is 2 centimeters to 5 kilometers. Okay, 2 centimeters to 5 kilometers is the scale. This is 9.6 centimeters. So what is that equal to in kilometers in reality? How do we get from 2 to 9.6? What do we multiply 2 by? So we'll do 9.6 divided by 2, which is 4.8. So 2 times 4.8 gives us 9.6. So we'll do the same here now. 5 times 4.8, which is 24 kilometers. But we need to give our answer in miles. So we know that 1 kilometer is equal to 0.62 miles. What about 24 kilometers? So 1 times 24 gives us 24. So we'll do the same on the other side. So 24 times 0.62 gives us 14.88 miles. You are using a map with the following information displayed. 2 inches equals 10 miles. On the map, your home is 7 inches away from your workplace. What is the actual distance between your home and your workplace? Show your working out and write the answer in the box below. So 2 inches equal 10 miles. What about 7 inches? So how do we get from 2 to 7? 7 divided by 2 gives us 3.5. So we'll do the same on the other side. 10 times 3.5 gives us 35 miles. You're using a map with the following information displayed. 1 centimeter is equal to 5 kilometers. On the map, two cities are 25 centimeters apart. What is the actual distance between the two cities? Show your working out and write the answer in the box below. So the scale is 1 centimeter to 5 kilometers. The distance is 25 centimeters. So what is that equal to in reality? So how do we get from 1 to 25? By multiplying by 25. So we'll do the same here. 5 times 25 gives us 125 kilometers. Two houses are 160 meters apart. They're drawn on a map with a scale of 1 to 1000. How far apart are they on the map in centimeters? So the scale is 1 to 1000. The actual distance between the two houses is 160 meters. So I'm going to put meters here as well, because if we use meters for one of them, I'm going to use meters for the other one as well, because the scale doesn't have any units. So this must be meters as well. So how do we get from 1000 to 160? So what we're going to do is 160 divided by 1000, which is 0.16. So 1000 times 0.16 gives us 160 meters. So we'll do the same here. 1 times 0.16 gives us 0.16, and it's meters. So we're going to give our answer in centimeters. We know that in 1 meter there are 100 centimeters. What about 0.16 meters? That is 16 centimeters. But if you don't know that by heart, you can just do 1 times 0.16 gives us 0.16. So we'll do the same here. So 0.16 times 100 gives us 16. So that is 16 centimeters. Anya is organising an outdoor concert. Anya is planning where to put refreshment stalls. There will be 3 rectangular food stalls, each measuring 6 meters by 2 meters. 2 square food stalls, each measuring 4 meters by 4 meters. 1 rectangular drink stall measuring 6 meters by 3 meters. There must be at least 2 meters of space between stalls. The centimeter grid represents a scale drawing of the area she can use. On the grid, 1 centimeter represents 2 meters. Draw a possible plan for the stalls on the centimeter grid. As 1 centimeter represents 2 meters, the rectangular food stalls, there will be 3 square lengths by 1 square length, so half of the number of meters we've got. The square stalls, there will be 2 square lengths by 2 square lengths. And then the rectangular drink stall, that will be 3 square lengths by 1.5. And the space between the stalls, that will be 1 square length. It doesn't say whether we can put them in corners or not, so that means we can do it if it doesn't specify. So 3 squares by 1, leaving a gap of 1 square length, and then I do another one, and then I can do a square food stall here, 2 by 2, and another square food stall here. So we've done these 2. We need 1 more rectangular food stall, which I'm gonna do it here. So we've done the rectangular food stalls as well. Now a rectangular drink stall measuring 3 squares by 1.5. So I could do it here. So 3 by 1.5. And we've got them all. And we've kept the distance between the stalls as well. John makes handbags to sell online. John wants to make 50 handbags. For each handbag, John needs a rectangle of leather measuring 35 centimeters by 20 centimeters. He cuts the rectangles from sheets of leather measuring 120 centimeters by 100 centimeters. The grid on the opposite page is a scale drawing of a sheet of leather. John says, I need 4 sheets of leather to make 50 handbags. Is it correct? You must use the grid to help you. You must show your working. So here is the grid. 1 centimeter represents 10 centimeters. And we've got space for working out. So each sheet of leather measures 120 centimeters by 100 centimeters. As 1 centimeter represents 10 centimeters, this will be 12 square lengths by 10 square lengths. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 1 sheet of leather. What he needs for 1 handbag is 35 centimeters by 20 centimeters. So that is 2 square lengths by 3.5 square lengths. So 2 by 3.5. Let's do another one here. 2 by 3.5. And we continue, so we've got 4 so far. 6, 8, 10. To try and maximize the number of these patches we can get, I'm going to go down this time, so 2 by 3.5. So again, 2 by 3.5. Two by 3.5. And now another one, 2 by 3.5. Even if I went horizontally, it'd have given me the same number, by the way. So it didn't make any difference that I went vertically, I went down. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 handbags can be made with one of these sheets of leather. and he says that he will need 4 of them. So 4 will make 4 times 15, which is 60. If he purchased less, so let's say 3, that would be 3 times 15, which is 45 bags, and that wouldn't be enough because he needs to make 50 bags. So we're going to say that yes, he is correct. And that's the end of the questions.